Now that you know a little bit about the 4 basic instruments that you'll be using for your lab experiments from lesson number 1, let's now focus on how to properly scale waveforms on the oscilloscope. Hi, I'm Johnny Hancock, Product Manager for Keysight Technologies Infinivision Oscilloscopes. Let's pick up where we left off in lesson number 1. So here you can see our 2 waveforms from the resistive divider circuit. But you know, you're not likely to walk into your lab and see it already set up for you. In fact, it could be in a very strange setup condition, special modes that one of your fellow students used in the previous lab session. So my first recommendation is to press default setup. Now in your scope it may be called preset or maybe clear. Here's default setup here. And so when we press default setup, it's going to go to a standard configuration. It's not going to be set up right, but it turns off all special modes. Now, after pressing default setup, there are 3 main things you need to adjust: the vertical scaling, the trigger level, and the horizontal. So let's take a closer look at the front panel over here, and there are those three adjustments are in 3 sections of the scope. This section here is called the vertical scaling section, and it's usually located just above the input B and C's. And then there's the horizontal section, that's this top section up here, and the trigger section, and this is the trigger level knob. Now, these 2 sections, the horizontal and trigger, on different vendors' oscilloscopes, they could be located in different places. So my suggestion to you is look at your scope and find those 3 sections: vertical, horizontal, and trigger. So what do we mean by adjust the vertical scaling? So here's the vertical section. There's a big knob there. Now some scopes, there are dedicated scaling knobs for each channel. In this particular scope, there's 1 set of scaling knobs, and they're multiplex. So if I want to adjust channel 1, I press the 1 button, rotate the knobs, 2, rotate the knobs, and so on. Now, let's adjust the vertical scaling. We can see our sine wave here from the default setup. It's a bit too small, so let's expand it. Now that's expanded too high. You want it to fill up at least half of the screen. If I click it, then I get a fine increment of adjustment. Click the knob again, I get big jumps. Okay, now notice as I'm changing this scaling, this number up here is changing. We'll get back to that in just a minute. The next step is to adjust the trigger level. Now triggering is really important, and we're going to get to that in a later lesson. So this is the trigger level. As soon as I rotate the knob, a horizontal line pops up and shows me where the level is. If I move it up above the waveform, the scope loses trigger. And I haven't explained what that is yet, but all you see is a blur of signals. So for now, just set it about the middle of the waveform. The last step in setting up scaling is the horizontal. How is it scaled horizontally? If I rotate this large knob up here in the horizontal section, rotate it clockwise, now it's spreading the signal out, showing less cycles. If I rotate it the other way, it shows more cycles. My suggestion is to get a couple cycles on screen. And if you rotate any of these knobs the wrong direction, just go back the other direction. It's very easy. Okay, so now we got the input signal. This is channel 1 of the oscilloscope. It's probing on the V-in of our circuit. What about the output, the voltage across R2 to ground? Let's turn on channel 2, so I'm probing in the proper place. And now we just do exactly like we did before, but now we only need to scale the vertical. The horizontal is already scaled for us, and we're triggering on channel 1. We don't have to adjust those. So now we just, again, adjust the vertical scaling knob. Again, you can see this number change, and now you can see the channel 2 waveform, which is V out across R2. Now back to those numbers at the top of the screen. Up here, you can see this says 2.00 V/ volts per division. It doesn't say division, but that's what it means. That's telling you the scaling of the channel 1 waveform. And so we can use that to get an estimate of what the amplitude is of the channel 1 waveform. And so let's see how big is the channel 1 waveform. I'm going to reposition it a little bit here, position it up here. And so there are divisions on screen. That's these white lines. The distance between the white lines is called a division. The yellow waveform, Vn, from top of R1 to ground, 1, 2, 3, 4, 5. It's about 5 divisions high, times 2 volts per division tells you that it's about 10 volts peak to peak. That's exactly what we expect. Now, what about the channel 2 waveform? Now, it looks like it's the same size as the channel 1 waveform, but it's not really, because the scaling factor says 200 millivolts per division, or 0.2 volts per division. And so we can, again, count the number of divisions, 1, 2, 3, 4, 5, times 200 millivolts per division is about 1 volt. Again, exactly what we expect based on the schematic, the circuit that we're probing. What about timing? This number up here, notice if I change the time scale, this one also changes, tells me what the horizontal scaling is. So what is the period of one cycle? I can see that it's about 1, 2, 3, 4, 5 divisions wide times 10 microseconds per division tells me that it's 50 microseconds for one period. If you take the reciprocal of that, that tells you what the frequency is. It's 20 kilohertz. And that's exactly what I have set as the output of the function generator. Now I'll let you in a little secret. There's a special button that you shouldn't use. It's called auto scale. It will automatically set up the scope for you. Now in your scope it may be called auto set or something like that. I suggest not using that button. First of all, it doesn't always work. If you have a very low frequency signal, it won't work. If you have a very complex signal, it won't work. And most of all, you're not going to learn how to use the oscilloscopes. And your professors or lab coordinators, there's a command that they can download into the scope that they can get from our company that disables that button so that you learn how to use the scope. You've now got the basics on how to set up your oscilloscope and properly scale waveforms. We also covered how to make quick estimated measurements of your signals by counting divisions and multiplying by vertical and horizontal scaling factors, which was the only way they could be performed back when I was studying electrical engineering in college. Later during this video series, we'll talk about better and more automated ways to perform measurements on your waveforms. But in our next lesson, lesson number 3, we need to take a step back and talk about probing. How do we get the signal into the oscilloscope in the first place? Remember, Keysight has lots of technical resources on oscilloscopes for engineering students that you can download at the URL listed on your screen. One of those resources is this poster that you can download. This poster summarizes what we just covered in lesson number 2. You might want to talk to your lab coordinator into hanging this poster up in your circuits lab, or if you're a super engineering geek, you might want to hang it up in your dorm room. Nothing wrong with being a geek. Without us geeks, this would be a pretty dim world. See you in lesson 3. Go North Carolina A&T Aggies.